Glad to have you back. In this video, we are going to learn our next scheduling algorithm, round-robin scheduling. This algorithm is designed especially for time-sharing systems. It is similar to first-come, first-served scheduling, but preemption is added to enable the system to switch between processes. Each process gets a small unit of CPU time called time quantum or time slice, usually 10 to 100 milliseconds. After this time has elapsed, the process is preempted and added to the end of the ready queue. Here, the ready queue is treated as a circular queue. Now, let's see how we can do the implementation of round-robin algorithm. In this case, we need keep the ready queue as a first-in, first-out queue so the new processes can be added to the tail of the queue. Then, the CPU scheduler picks the first process from the ready queue, sets a time to interrupt after one time quantum, and dispatches the process. Two things can be happened when implementing round-robin scheduling algorithm. The first one is the process may have a CPU burst of less than one time quantum. Here, the process itself will release the CPU voluntarily. The scheduler will then proceed to the next process in the ready queue. The second one is the CPU burst of the currently running process is longer than one time quantum. Here, the time will go off and will cause an interrupt to the OS. A context switch will be executed and the process will be put at the tail of the ready queue. The CPU scheduler will then select the next process in the ready queue. Let's look at some terms related to the round-robin algorithm. The completion time is the time at which process completes its execution. The difference between the completion time and the arrival time is called the turnaround time. The difference between the turnaround time and the burst time is called the waiting time. Now, let's discuss an example of round-robin algorithm. Consider the following set of processes that arrive at time 0, with the length of the CPU burst given in milliseconds. If we use a time quantum of 4 milliseconds, then process P1 gets the first 4 milliseconds. Since it requires another 20 milliseconds more for completion, it is preempted after the first time quantum, and the CPU is given to the next process in the queue, which is process P2. Process P2 does not need 4 milliseconds, so it quits before its time quantum expires. The CPU is then given to the next process, which is process P3. Once each process has received one time quantum, the CPU is returned to process P1 for an additional time quantum. The resulting round-robin schedule is as follows. Let's calculate the average waiting time for the above schedule. P1 waits for 6 milliseconds, that is 10 minus 4, P2 waits for 4 milliseconds, and P3 waits for 7 milliseconds. Therefore, the average waiting time is, 6 plus 4 plus 7, is divided by 3 equals 5.66 milliseconds.